AAS atau Atomic Absorption Spectroscopy adalah suatu metode analisis kuantitatif yang digunakan untuk penentuan kadar unsur-unsur logam dan metaloid berdasarkan prinsip penyerapan cahaya pada panjang gelombang tertentu, menggunakan absorption optical radiation pada atom bebas dalam keadaan gas. Metode ini sangat tepat untuk analisis zat pada konsentrasi rendah.
Describe in brief the main components of atomic absorption spectrometer. The main components of the instrumentation used are as follow. 1. Source of radiations. It is a hollow cathode cup. It consists of the glass jacket containing cup-shaped cathode, made up of the same element which is under study. A tungsten wire or plate acts as anode, which is arranged in the same glass jacket. The glass jacket is filled with the inert gas like neon or argon at a low pressure. When a potential of 500 to 1000 volt is applied between the two electrodes from the power supply, the atoms of the inert gas is ionized. The positive charged ions are moving towards cathode. These fast-moving ions remove the atoms from the surface of cathode. This process is called sputtering. These metallic atoms then collide with highly energetic gas ions, and some of them are excited. These excited metal atoms, when returned to the original ground state, they emit their characteristic radiations. 2. Rotating chopper. A rotating wheel having several holes in it brooks the beam of light coming from cathode lamp and produces intermittent or broken light beam. 3. Burner. The flame is produced by burning the fuel with the oxidizer, and the sample is kept in the beaker which burns in the flame. Burners used are of the two types: total consumption burners and premix burners. 4. Monochromator. Either prisms or diffraction gratings are used as monochromator. The transmitted beam from the flame enters the monochromator. Monochromator separates the beam of light in different wavelengths, and only one wavelength is allowed to pass at a time to photomultiplayer 2. 5. Photomultiplayer 2. The transmitted light from the monochromator, when falls on photomultiplayer 2, the current is produced. This current is proportional to the light incident on the photocathode of photomultiplayer 2. 6. Readout meter. This dial will give us the amount of radiations absorbed by unexcited atoms present in the ground state in terms of the absorbance. Working. The cathode and anode are connected with the power supply, from where we supply the potential of 500 to 1000 volt. The gas taken in the bulb is ionized. The cations of the gas are moving fast towards cathode, and remove the atoms from the cathode. These atoms strike with the gas ions, and transition of electrons take place from ground state to excited state. When these excited electrons return to the original ground state, they emit the characteristic radiations, which pass out of the mica wall, and are incident on rotating chopper. Rotating chopper produce intermittent radiations, which are incident on the unexcited atoms present in the flame of the burner. These atoms absorb the radiations. The transmitted radiation is incident on the prism, which is connected with the photomultiplayer tube. In photomultiplayer tube, current is produced. Photomultiplayer tube is connected with readout meter, which gives the absorbance. Now, by applying the Beer-Lambert's law, we can find out the concentration of solution by knowing the absorbance. Applications. 1. Quantitative analysis can be done using calibration curve method. 2. Very low concentration, which is 1 ppm or less than that, can also be analyzed accurately with the help of AAS3. With the help of AAS, we can detect the toxic elements such as copper, nickel, zinc present in food products. 4. The phenomenon is used to estimate sodium and potassium present in blood serum. 5. How much amount of lead is present in the petrol can be found out with the help of AAS6. Solely extracts, plant materials, fertilizers have been analyzed for determination of sodium, potassium, magnesium, molybdenum, vanadium, etc. 7. The amount of titanium and vanadium present in the steel alloy can also be determined with the help of AAS. Limitations. 1. Simultaneous analysis of many elements is not possible. 2. Metals like lanthanum, tungsten, silicon etc. form the stable metallic oxide and so cannot be analyzed. 3. For alkali metals like lithium, sodium, potassium etc., which has low ionization potential. In such cases, low temperature of flame is required to minimize the ionization of the elements. 4. Each element requires the separate lamp. 5. If the sample contains two elements which absorb the light of same wavelength. For example, manganese and gallium both absorbs at 403 nanometers cannot be analyzed. In such case, we must remove the interfering radical.